A honey badger is killing a cobra. The snake bites first. It lands cleanly, and it delivers a full dose of venom, enough to stop a grown man's breathing in under an hour. The badger keeps fighting. Then, some minutes later, it goes down, stiff, unresponsive, beside the dead snake. And then it wakes up, gets to its feet, and finishes eating the animal that just poisoned it. The venom wasn't weak. It wasn't a dry bite. It went in, reached its target, and worked exactly as designed. Nothing happened. You've heard why. The honey badger is fearless. It has thick, loose skin. It has an attitude. All of that is true, and none of it explains this. Skin doesn't matter once the venom is inside. Attitude doesn't matter to a molecule. Cobra venom isn't a poison that burns through a body. It's a key shaped over millions of years to fit one specific lock. A lock you are carrying right now. It's how you're breathing as you listen to this. The badger has that same lock. The venom found it. And the badger got up. So what happened at the lock? Cobras belong to a family of snakes that don't rely on destroying flesh. They go after the nervous system. Their venom carries molecules called alpha neurotoxins, and those have exactly one job. They find the receptor that sits on every one of your muscle cells, the point where a nerve tells a muscle to contract, and they sit down in it. They don't break it, they occupy it. The nerve keeps sending the signal. The muscle stops hearing it. Your limbs go heavy, your eyelids drop, and eventually, the muscles that move your chest stop answering. You stay awake for it. That's the part people don't expect. And here's why that receptor is such a good target. It's called the nicotinic acetylcholine receptor, and it's one of the most conserved structures in the animal kingdom. Fish have it, frogs have it, pigs have it, you have it in essentially the same form. It hasn't changed much in hundreds of millions of years, and not because evolution wasn't paying attention, because it can't change. That receptor is how every voluntary movement in your body happens. Alter it, and you don't get a better animal. You get an animal that can't move, which makes it the perfect thing to attack. Every mammal is carrying it, and no mammal can afford to redesign it. Except, apparently, 4 of them. In 2015, a biologist named Danielle Drabeck decided to find out how. Honey badgers are not easy research subjects. She worked with zoos to get blood samples, extracted the DNA, and sequenced the gene that builds that receptor, looking for whatever it was that let this animal walk away from a cobra. She found it almost immediately. The gene had changes, small ones, a handful of substituted amino acids, all clustered at exactly one place on the receptor, the spot where the toxin docks. The badger hadn't evolved a shield or an antidote or a way to break the venom down. It had changed the shape of the doorway. The change is almost absurdly small. Where most mammals have a neutral amino acid at the toxin's landing site, the honey badger has a positively charged one. The toxin arrives carrying its own positive charge, and the two push apart. It can't settle. It drifts off, still fully loaded, still capable of killing almost anything else. But look at what that change had to avoid. That same receptor still needs to catch the body's own signaling molecule, acetylcholine, thousands of times a second, or the badger can't breathe either. So the alteration had to reject one molecule while continuing to accept another one that lands in the same place. It's not armor. It's a lock, retooled to refuse one specific key, and only that one. Then, Drabeck compared the honey badger's version to other animals. Hedgehogs had it. Not inherited from a shared ancestor, arrived at separately. The same trick at the same site. Pigs had it too. And mongooses had solved it a completely different way. Same receptor, same landing site, but instead of changing the charge, they'd hung sugar molecules over the spot. The toxin can't dock because something bulky is already parked there. 4 lineages, 2 entirely different solutions, the same few positions on the same ancient molecule. Nobody copied anybody. They were separated by tens of millions of years of evolution. They just kept arriving at the same door and finding the same 2 ways through it.
And it isn't only mammals. The same kind of resistance has since turned up in Australian skinks, in burrowing amphibians called caecilians, and across a wide sweep of African carnivores that hunt snakes. Every one of them faced the same weapon. Every one of them ended up modifying the same handful of positions on the same receptor. Evolution had an enormous molecule to work with, and hundreds of millions of years to be creative with it. It kept picking the same spots.
Which says something about evolution that doesn't match the way we usually describe it. We talk about it as endless invention, a process spraying out variety in every direction. And there is a staggering amount of variety. But this receptor shows the other half of it. Given the same problem, the same molecule, and the same constraints, evolution doesn't wander, it converges. There were only ever a few positions that could be altered without breaking the animal, and life found them, over and over, in separate lineages, tens of millions of years apart. That makes evolution far less like an artist, and far more like a lockpicker, working a mechanism with only a few pins. And a mechanism with only a few solutions is a mechanism you can read. We still make antivenom the way we did a century ago, by injecting horses and sheep with venom and harvesting their antibodies. The honey badger's answer isn't an antibody at all. It's a spelling change.
So picture it one more time. The badger on its side, beside a dead cobra, breathing slowly, with a full dose of neurotoxin circulating through it, and nowhere for that neurotoxin to go. It isn't tough. Toughness has nothing to do with it. Its skin didn't help, its attitude didn't help, and the venom was never weakened. Somewhere in its DNA, there is a misspelling, a few letters different from yours, in a gene neither of you chose. And because of it, the most refined chemical weapon in the natural world arrives at the door and finds the shape wrong. You're carrying the original spelling. So is nearly every mammal alive. The venom was built for us. The honey badger doesn't care. It's not being brave. It simply cannot be told to stop.